Hello everyone, welcome back to our YouTube channel, Becoming a ROS Developer here at The Construct. My name is Rodrigo, and today we have one of our students, BH, who has completed one of our courses. This is ROS2 Basics in 5 days. And how this course works is that you can obtain a certificate if you present a project at the end of, when you finish this. And this project is what we're going to see today on a real robot. So the student has performed this project, and then we're going to be seeing how he did it. Hello, BH, how are you doing?
Hi, how are you, Rodrigo?
I am very well, thank you. I'm
Thank
very
you.
excited to see your project. So whenever you want, please go ahead and share your screen so we can
Okay,
look at your project.
right. So let me share my screen for starting from what I have done,
All right,
and
we
then
can
I
see
will
your
show you
screen now.
the demonstration of how the operation moves.
Mm-hmm.
Okay, so the first slide is I'm gonna start from the code first. So this is the main.launch.file I'm gonna execute at the beginning, and this is consists of three nodes. The first node is a world finder service server node. And
Mm-hmm.
what is the function of this the server is when this is called, they start world finding behavior. And then you can see here the motion sequence that they're looking for, the wall first and approach them, and then told to turn to the parallel to the wall. So maybe you cannot see the small letters now, but I can show you more detail in the when the robot moves. And then after that, they start another node, which is the odom recorder. So when this action server is called, they actually start to recording their position for every second, so that you can see the
Uh-huh.
detail of how do they, they call the positions by odom recorder, and how do they append into list array. And then this is the main file. The After this action server and the service server is turned on, so the following pi, this program will be starting. So they start from the calling the world finder service first. After that, they finish the world finding, and then they start call odom record the action server, so that they start recording. And at the same time, they will do the all following behavior together,
Mm.
so that this consists of two main classes. So as a result, you will see the result that we will see the three main, the node will they started, and then after that, the wall finder service completed, and then robot will be parallel to the wall, and then they send out the wall finder service, the interface to be the yes, so that not true, and then they start the next action for action server start, and then they send the goal and accept it, and then they are starting feedback, so that you can see the every 1 second they are sending feedbacks.
Uh-huh.
And at the end of this, I'm sorry, do you have any feedback?
No, no, so far so good. Very clear.
Right. So at the end of this action complete, the mission is to be 5 centimeter to the start point, and then they send out all the position of record in the list format, so that you can see the result here. So in my previous trial, I was able to stop the robot in the 2 centimeter away from the starting point
Oh,
when I was
wow.
lucky. Yeah, but sometimes I was not lucky, so that it's slightly away. So that for the demonstration today, I put the criteria more looser, and I'll explain why we cannot beat that always happen.
All right.
Okay, and then I will go back to the robot, and then I will start this robot program. Okay, give me a second. Two.
Okay, we can see the robot now.
Well, okay, so I will start this and close this. So you can see the robots. Right. And now the robot is turning to the wall.
Mm.
and then
What's that
seeing the
number?
index.
Oh, the
Yeah, numbers is
index.
the index. They're heading for 360, and then going to the numbers to 2.7, 27 centimeters,
I see.
and then running parallel to the wall, and then they turn to the true to the service interface,
Yeah.
and then they start recording. So
Okay.
every 1 second, you will see they are sending out each data point, and also recording. I mean, they're measuring the distance to the origin, and also they are sending the feedback to the main wall following the node.
Okay.
Okay.
So that distance to origin, that's the distance that a robot has traveled, or the actual distance to the like. So is that the whole trajectory of like?
No, this is okay. You can see the current total is the total distance
Oh,
of
I
the
didn't
travel.
see the bottom one.
Right.
I see. I see. I
And then
see.
the distance to origin meaning the distance to starting point.
Right, which is what you use for stopping.
Stopping. So,
Okay, I see.
yeah. So let's wait whether they can stop on the right positions.
Uh-huh.
But sometimes I miss the point. So today I put the criteria as more looser.
Right.
So that, right. Okay. So at the end of this, the
Well, that was pretty good.
goal,
That
we
was very
see.
close.
Yeah, so actually, no, it's not very close, but I can even make it more closer. But for the demonstration today, I made it more
Yeah.
looser.
Makes sense.
Okay, so this is the data point of all the
Uh-huh.
recorders. Right. Let me go
Yes.
back to the PowerPoint again. That um, so the
Yes, because we
so,
saw this work really well. So awesome.
yeah. Thank you. Any other comment? Yeah.
No, no, I'm sorry to
Right.
interrupt.
So I was working on the simulation first, and then I find out there's a big difference to the remote robot.
Indeed.
Then I send out the topic scan, the echo messages, and then they find out where the scanner started, and then how much is each data point. So that is very different. That's why I have to make two programs separately for simulating robot and then or simulation robot and then also the actual robot in your Spain.
Uh-huh.
Right. Okay. So you can see this one, they start from the front and then turning to the right and then come back to the 360, 395. And then the actual robot in your Spain, your Barcelona, they start from backside and they're turning like this one, and then turn back. The data point is what 720. That's why it was very different.
Right.
Okay.
So double the amount of points and oriented upside down,
Right,
basically.
right. Upside down. Also, the incremental was different. Right. And then I was thinking some fun over here, just like how to define the distance from the wall. So in the instruction, you are asking whether self laser right should be the distance to the wall. But I was thinking whether actual distance to the wall will be, the smallest distance from the center of the robot to the
Oh,
wall.
yeah.
So that's why I said I need to define the distance, which is more nearest of the wall.
Mm-hmm.
They can make more precise motion. So normally it should be okay, but when the robot is turning very sharp, I believe there's a big difference between the self laser right and then the distance to the wall.
Absolutely. It can,
Right,
yes, yes.
right. And then there was some strategy I have to hit the circle more high probabilities. So when I follow the simple go straight zigzag motion like this one, so that it's highly possible to miss this circle, which is we cannot hit the
Right, because it's kind of going in a zigzag motion.
right. So then I change the code slightly to kind of the integrate. I mean the p function, proportional function, so that they are depending on how far they from going straight. Actually, I want to make them to go straight when they come into this 20 to 30 meter ranges, so that they can have more chance to hit the circles.
Oh, I see what you're doing there with the min index
Right.
and then using that for the angular. That results in a smoother line then.
Absolutely. Yeah.
Ah.
And go straight mostly.
Ah.
Right. I don't want to try just unique one. Actually, I found some people try the PID function. It's very smart,
Yes.
but yeah, but I don't have the time, so I just use a very simple.
No, and I mean, if these two diagrams are true, if just by setting that main index as the angular, that's amazing. That's a almost I would say yeah, that's better. That's easier and gets to the
Easier,
point.
easier. Only
Yes,
one line, and then okay.
exactly.
And then this is the detail of the how do I record the autumn record. I try to strictly follow your instruction. So
Uh huh.
all the variables here is exactly the same as what you're requesting for. And then what I did was a little bit interest was you mentioning the setter, but actually you do not use this setter in other rest of the instructions. So I
No,
captured the setter value from the orientation and then put them into the autumn recorder.
no. Yes, you're right. This is just to. So in
Hmm,
theory, this would be a trajectory, right? The
right,
the, the list
right.
that gets spit out. You could use
Hmm.
that to plot trajectories, and so including the orientation of the robot at each point. But
Right,
yes,
right,
you're
that's
right.
right.
We don't really need
Right.
it in theory.
Absolutely, we need this one. That's why I here he doesn't have the G mentioned here. That's why I put as an additional value. Okay, and then there were some the tricky things about how to meet the 5 centimeter requirement. So if you make robot go slower, so it means you have more checkout point, so they will have
Mm-hmm.
more chance to hit this target. But if you move so fast, and then you will have lesser chance to hit it.
Ah,
Also, you can set the starting point more close to the center of this, the center of this, the 20 centimeter, 30 meter, so you can
yeah.
have more chance to hit it. Yeah. In my case, I used to use, the 10 centimeter for the sec. That's why I used to miss a lot. But in actual demonstration I show you, I just use a point 8 centimeter per sec. That's why I could it better. Yeah.
Okay.
And then, as a summary of this, my experience, there was some difficulty during this quiz, solving quiz. The first one was instruction was something different from what I was expecting. That you're asking to, type this service call
Yeah.
interface, but it doesn't work at all. That's why I changed it to this one and then working. Right. And the other one is data format for the Odom recorder action interface. I try many actually. The originally instruction shows to put the message in the middle, but it doesn't work. Even though I tried 100 times. Even also I try some other types of the data format doesn't work, and then finally find out this is working. So at the end of this repeating, I found some people already know this one.
Yes,
And the other one,
yes. I should. It should be a point. The difference is the type of the message.
right? Oh,
This is
but it doesn't
64. The
work.
other one's
Yeah.
32.
It didn't work when I put the message in the middle. It doesn't work. So
Wait.
that if I put this way, so I can get this clear the inform and maybe array informations. The other one is dependency setting for the action interface. So when I use a Odom recorder action input is the ROS IDL. But if you don't have this line, it doesn't work. So that I found someone from your one of the presenter. I really appreciate him. And then when I adding it doesn't work. The other one is kind of the Python coding. Uh, if I don't use copy of this the appending function, it turned out to they actually updating the only one value on the last values. That's why I asked for this one, the ChatGPT, and then also working with my program friend, and the copy was working well. That's why I could get a very nice the result here. That they are all different numbers each data point. Otherwise, I see they're always showing the last point without updating
Uh,
the yeah.
that all makes sense. Let me just mention the first part. You
Mm.
know why that's happening? Why the one the one on the notebook, so in the instruction, doesn't work, and why the
Oh,
one that you are writing below does?
this one. Oh,
No, on the left. So
on the left, this one.
yes,
This one.
this. Do you
I
know
see.
why that's happening?
I didn't know actually. I used the custom messages, but it didn't work. I didn't know.
Exactly, because that means that your service find
Right.
wall,
Yeah.
it you made it of type wall follower messages. It's a
Mm.
custom message.
Yeah. Right. Custom
The
messages.
other way, you could have also done it with a simple standard, which is an empty message, and that's
Oh.
why. So yes, in this case, if you make your service a custom
Oh.
service of the
Right.
package wall follower messages service, then you're gonna have to do
Mm.
that. And there was no way that the other way is gonna work unless you made a standard message call for a service called FindWall. That's all. All
I
right.
see.
Awesome.
Right. Okay. So let
Sorry.
me go back to this robot again. Right.
Keep going,
Yeah.
please.
Yeah. That's the whole my story. So
That's
all
all?
the files here, and I think it's very straightforward. Actually, just
I don't
following
think we
your.
even need to look at it. First of all, you have a
Oh, okay.
really
Okay.
large screen and it
Right.
translates to really small letters.
Right.
So,
Right. Right. Right.
but no, that's okay. You
Let me
don't
go.
have to
Let me
show
go. Let me
us.
go. Right. So that
Okay,
is starting from World Finder. So I create the service server, right? And then regarding this mutually exclusive callback, I even don't have to use all of them. Actually, I can use only two of them. But when I copy, I just copy all of them so that
correct.
they're actually having two different the callback groups, right? And then when the laser callback is called, and then they are updating the latest value of these laser scanning values. And then I define a couple of the method for each motions. When you go to the main motion, which is happening by empty callback, so they go to the turn to the remote first, and then after that approach, and then the parallel to the wall and stop, and then they send out the true value for the service messages and the return response.
Mm-hmm.
This is the wall finder coding.
Okay.
And then the odom recorder coding is uh, the same. Actually, I didn't even have to use all of them, but I'm using the two groups here, two groups of, I'm sorry if the screen is small, two groups. Then we start action server, and then this is the subscribing the odom data. Then I define all those variables here.
You
There's a
have
couple of
5
here.
more minutes.
Okay, and then when the execute started, they follow this routine so that they're recording the first point, and then after that they keep recording the next data point, and then after that they're sending the succeed result, and then they are sending out the uh, list array data, right? And this is all following. When the action server and the service server is turned on, they are calling out first. They are calling out the all find by this sending request, right? And then after that, I made another class for all finding. So when this started, they call that we will create a client, and then this client is calling the action server by below method, this below the programs. And then at the same time, they do the wall following motion like this, as you shown in the video. Yeah, that's about it. So there's a lot of strikeout because I'm trying error many times, as you can.
That's good. That's a good sign. All
Right.
right. Well, very, very nice, BH. Do you mind? You're done, right? You're done with
Yeah, if you have more
presenting?
questions, you can. Yeah,
Great. Do you mind stopping sharing your screen so we
sure,
can
sure,
look at
sure.
our
Yeah,
faces for
right.
I have a couple of questions. All right, great. So, congratulations, BH. Really, really nice, a really clear presentation, and I mean, it worked perfectly. There's a couple of things I really like. First of all, I really like your diagrams and your presentations. They're very
Thank you.
clear. They show very clear of what issue you were tackling and how you were thinking about the problem. And
Mm.
I especially liked that thing I mentioned about adding the minimum index and doing some operations for that, and then inputting
Right.
that into the angular velocity.
Right.
I think that was very clever. Just with one line, you save
Right.
the work that someone might have done with a really complicated uh, PID controller to achieve
Yes.
the same goal, which is, don't
Yes.
go like
True.
this, go a little smoother. I thought
Yeah.
that was really cool. Um,
Mm.
and and just overall, very, very clear and simple. So I want to
Thank you.
congratulate you for that. And
Thank-
I guess my one question was about the service call,
Oh,
and then I
yeah.
guess I have the other question is when you find the wall,
Mm.
if you're closer to an obstacle, it would go to the obstacle.
It's true. Actually,
True.
that's why I have to put the robot away from the obstacle in the middle.
I see.
Right.
And this is not a requirement. I was just wondering if you had implemented that, and I didn't want to not mention that.
Mm.
But can you just to close it out? Can you think of another way of implementing, let's say, an action in some behavior, something like this, or basically what advantages you get from doing an action server as opposed to, let's say, a service server?
Right now, the action server is the autumn recording action server,
Exactly.
right? So
Right.
they are
And the
sending
service
feedback and
server?
then they're sending data. The service server is the kind of the one of the service. The service is a world finding service. The very simple task missions.
Uh-huh.
Kind of they're looking for a wall and they go there and then turn, and then that's the end of this service server.
Hmm.
But I don't know what is the question about your action server
So my
versus
question is
there.
basically, why
Mhm.
not use a service server as the odometry recorder? Why is that not possible?
Yeah, because of feedback, those actually the action server only have a response and request, but action server has the three items like sending goal, feedback, and result.
Right.
Otherwise, you cannot tracking this data point.
Yes, exactly. What I was trying to
Thank
get
you.
at. That
Actually, I clearly understand those the difference between topics and service and then the actions. It was very a nice system. I was really amazing by this system.
Yeah, because the service kind of blocks you, and while
Right.
the action you can continue to do things like record the
Mm,
odometry and doing that for the
right.
feedback.
Mm.
Yes, awesome. Uh, well, other than that, BH, I don't have any other questions. Very clear, very straightforward. So I just want to congratulate you again. Very well
Thanks so much.
done.
Yeah.
All
Thank you.
right. And for everyone else that is watching, this is what you can do when you take some of our courses. If you want to get a certification from us, is that you're going to take your learnings and present them here, like BH has done. So I invite everyone to do the same, and we'll see you guys in the next time. Thank you, BH. I hope to see you
Thank
around
you.
soon.
Bye bye.
All right, everyone. Bye bye. See you next time.
Mm.
All right, we're done, BH.